My name is Sam Krueger, and I am a second-year master's student working in Dr. Guo's lab at the UWM School of Freshwater Sciences. The research that I have conducted has been based on two projects, one of them being the comparisons on the extent of heavy metal contamination in sediments between Milwaukee Harbor Area of Concern region and the Bay of Green Bay Area Concern, as well as the reconstruction of the pollution history of heavy metals in these sediments of these areas, and the other has been assessing the leaching and degradation of microplastics and the release of dissolved organic material, or DOM, under various conditions. Heavy metals are contaminants that can have a wide variety of adverse effects on organism health and environmental health, and also can settle into the sediment of waterways. Milwaukee Harbor and Green Bay were both listed as an area of concern by the Environmental Protection Agency in 1987, with contaminated sediments being a reason for this. However, the contamination extents of heavy metals in sediments and historical changes over the last decades in both areas are poorly understood. Prior to my arrival at SFS, sediment cores were collected in both locations on the RV Niske, segmented into 1 to 2 centimeter increments and freeze-dried. To measure the heavy metal concentrations in these sediment samples, the samples were acid digested and then measured using ICP-MS, or inductively coupled plasma mass spectrometry. Upon analysis of the concentration data, it was determined that there were some differences in the trends of heavy metals between Milwaukee Harbor and Green Bay. Overall, the concentrations in Milwaukee Harbor were higher than the concentrations of heavy metals in Green Bay, indicating greater anthropogenic impacts from the Milwaukee metropolitan area. However, the general trend shows increasing concentrations in Green Bay while decreasing over time in Milwaukee Harbor. The cause of this increase and pollution sources are not known, and further investigation is needed. Switching gears to the other research project that I've been working on involving the degradation of microplastics and the weathering products, microplastic-derived DOM, under various leaching conditions. Microplastics, which are small plastic pieces between 1 to 5 millimeters in size, are a growing issue in the environment, as they can bioaccumulate in organisms as well as stunt growth. A variety of microplastics were used in this research, PVC, PHA, acrylic, and others. These microplastics were subjected to various conditions that would mimic what the plastics would encounter in the environment, such as UV irradiation, heat exposure, and water leaching. The goal was to analyze the degradation and resulting release DOM of the selected microplastics under these conditions to examine what would be released into waterways that are contaminated with microplastics. During the leaching and degradation experiments, time series samples were collected and measured with a UV-Vis spectrophotometer, TFC analyzer, and EEM fluorimeter. Based on our preliminary data, it was determined that PVC and PHA released the most DOM out of the selected microplastics. With this award, I was not only able to conduct this research, but also present my research at 2 different conferences: the Society for Freshwater Sciences annual meeting in San Juan, Puerto Rico, and the International Association for Great Lakes Research annual meeting here in Milwaukee, Wisconsin, were the 2 meetings I was able to attend. I would like to thank Dr. Guo for his guidance in this research and the Mick A. Naulin Foundation for supporting this research. Thanks again.